And then at the end of the telescopic bow gauge, unaona hapa, and also on this other side, which we can see, there are two arms that extend outwards. And you can push them inward, but even if you push them inward, there's a spring usually at the middle somewhere hapa. Kuna na coil spring hapa, katikati, just along this lower section hapa. So there's usually a coil spring that always pushes out those arms outwards, the two arms of the gauge. All right, they'll always be pushed outwards. So what happens is that you normally push the arms inward. Okay, these two. Okay, once you push them inward, you lock it with this knob. Ukilock na hiyo knob, it prevents the spring from pushing them outwards. They'll be locked in place. Okay. Once, if you release the knob, that is by untightening it, you untighten it in the clockwise direction, then these two arms will pop out. Okay. So kupima, if you want to now take the measurements, okay, ukitaka kuweka measurements, unaiweka hivyo. So you press them with your hand, the two arms, these ones, you press them with your hands, and then unaisukuma pale ndani kwenye kwenye cylinder. Unazisukuma and then unaiachilia. Ukiziachilia, because of the spring, they will naturally force themselves outwards. But now they'll be restricted by the shape of the cylinder. Now, once you've done that, you now tighten it using the knob. Hivi. So that ukiitoa, the arms will not change. I mean, they will not move inside or outside. So they'll have a definite measurement. Na hiyo measurement sasa kitu nafanya, you now take it to a vernier. Hivo. Unaona hivo? So you now take it to a vernier. Unaiweka tu kwa vernier, unapima. So ile value yenye itakuonyesha hapa, that is a measurement. And you can see the knob here is fully tightened. In fact, at this point, hata ukifungua, you untighten it, haiwezi ikaenda popote because now it is still restricted by the vernier. But you don't do that until you are done with the measurement. So once you are done with the measurement, then you do what? You untighten it, okay? And then you place it again at right angles to the first measurements. And right angles ni hivi. So now at right angles. You do the second couple of measurements, and then you record it again. The difference between those two measurements ni ile nilikuwa nasema inaitwa ovality. I hope you now relate. That's what I was calling it, ovality. And then pia unaweza isukuma pale chini. You can see, for example, this one, you're using a dial indicator. So kuna zile ziko na dial indicators hapa. So hii hautapeleka kwa vernier. Unaipima hapo, inakupatia measurement hapo. Zingine iko na digital meters, a digital indicator hapa. So the moment unaipima, and they are very highly sensitive, by the way. Hizo zinakonga highly sensitive. So it's not something that, I mean, you have to take extreme care of it. Si kitu ya kuangusha, uwezi ukaiangusha. The moment unaiangusha hivi, then you'll have messed up with the meter. So inakuwa ni very highly sensitive. And then again, it's always good to use in an environment where there are no electrical connections. Because electrical connections can also mess up with, for example, especially these kinds of dials. Inakuwa na some level of magnetism in them. You know the principle of electromagnetism. Any conductor that has current in it always has some amount of electromagnetism. So you always carry it in a place where there is no electrical connections, or you're far away from any kind of electrical connections and all that. All right. So kuna zile ziko na indicator, na hii ni rahisi sana juu unapima tu and then you record it. You don't have to take it to a vernier. Okay. So there's no loss of measurement. Okay. You become more accurate. All right. They are usually more accurate. Now, so you can also measure it below. Kama hii unaona anapima pale chini. You can see huyu. So hii unaweza pima pia pale chini vile nilikuwa nimesema, and then ukisha pima also pima at right angles to that one. Okay. So unapima, so umepima in this direction, unapima pia in this direction. Okay. Now ukipima in those two opposite directions, I mean those directions that are right angles of each other, then you can also record the measurement, and then from there you can obtain ovality, or you can obtain taper between, say for example, this one and na hii ya juu. Okay, between these two. So between these two you can still get taper, just like nilikuwa nimeelezea. Okay, and can be able to give you the degree of wear in this kind of engine. Okay, so that is how you use the vernier. Pia unaweza tumia instead of a vernier hapa utumie micrometer screw gauge, bado tu ni sawa, ama utumie tu directly the dial indicator, ile ambayo iko na dial indicator kama hii. Kuna zile ziko na dial indicators, they will give you also measurement. Okay, they'll also give you some measurement, then you just record it. Na ingine ambayo nimeongelelea ni hii crankshaft. So crankshaft unaweza pima direct hivyo. This is what I was saying. So hii part, you can see hii part hapa, hii the main bearing journal, while the one that is, that is the rod bearing journal. This is the offset part of the crankshaft. Okay, while hii ya katikati is the main bearing journal. Okay, that is like the main shaft itself, while ile ambayo iko offset kama hii, for example, this is the main one hapa, while the offset one here is the crank pin, or what you call the rod bearing journal. Okay, the crank pin or the rod bearing journal. So you measure both of them, and you can also be able to determine the degree of wear, okay, by using mobility. So itakupatia tu bado, okay, to still be able to give you. Na hii unaweza pima direct, na kama hii for example unaona napima tu direct na nini, micrometer screw gauge, ama unaweka vernier. Okay, same with this one, unaona natumia micrometer screw gauge. And I hope you know how to read micrometer screw gauge. So you should also be able to know how to read micrometer screw gauge. Okay. Anyway, and by the way, I've also seen some interviews, unapewa micrometer screw gauge, unaambiwa ama mtu anapata amepima kitu fulani, and then anakuambia you read uandike hiyo reading iko kwa micrometer screw gauge. Yeah, especially if you are seeking maybe unataka kuwa systems engineer somewhere, unataka kukuwa maintenance lead maintenance engineer or something like that. Okay, it's always important that some of this, and sometimes interviews zinakuanga tu vitu funny. Some of the funniest things you'll be asked, unapewa tu a reading hapo kwa vernier ama micrometer screw gauge. Yeah, we used to do that when we were hiring some students to work on some projects way back. Na tukishaona tumepata tuseme we need like 5 of them and we still have like 8, yeah, tunapatia something like that, and then we just gauge. And sometimes it's not really a measure of how good they are with their work, but it also sometimes tells you about how serious they take whatever it is they learn, especially in the small technical details like reading this kind of instruments. Now moving on. So hii sasa ni ile nilikuwa nasema ni ya flatness test. So kwa flatness test, so kuna kitu moja nimesema, hii ndio inaitwa straight edge. Okay, hii ndio straight edge. So straight edge hii kitu inakaa ruler, it's just metallic, something that is metallic and a little bit heavy. So you always place it, you can see this here, this is the cylinder head. Here is your cylinder block or the engine block. This is the cylinder head, you can see here. You can see how it looks like. So ukishaweka, you keep putting, so these ones are called, this one here, okay, the whole of these is called a filler gauge. Hii yote inaitwa filler gauge. So filler gauge iko na what we call leaves. Hizi leaves, majani, kama majani, okay, leaves. I don't know whether I can write here. Okay, leaves. So they're called leaves. Now these leaves have different thicknesses. So utapata the least thickness inaweza kwa tuseme ni hii, for instance. Utapata ni kitu kama 0. The ones zenye tuko tunatumia zilikuwa zinaanza na 0.05 millimeters. Okay. So 0.05. And then the thickness inaongezeka by 0.05 millimeters, which means the next one would be 0.1 millimeters, 0.15, 0.2, 0.25 millimeters, like that. So thickness inaongezeka. So kitu kwanza ukishaweka the once you've placed the straight edge, you keep checking. For example, if you see this image here, hii hapa nimeonyesha hapa, so if you see that image, you place it at diagonally. So you can choose to check the parts, so different parts. So you check, for example, you can see that you can start with 1. You can call that 1. You place the filler gauges under the straight edge. Okay, and the straight edge is not supposed to be pressed so hard. You're only supposed to hold it in place. So one hand holds it in place without any much pressure, without any significant pressure. And then now you place it under the what? You place it now in the area. You can start with 1 and check if the kama ile ya 0.0, you start with the 0.05 millimeter, the one with the least thickness, and check if it passes through. If it doesn't pass through, go to, for example, 0.2. You can see kama ameweka 0.2. Check. Okay. Unaweza pata maybe haiendi through. You leave that. You can go to 0.3, for example. Kama hii ni 0.3. So 0.3, it could be say somewhere here. Okay. So 0.3 inaweza kuwa iko hapo. Now, say at 0.3, hii ya 0.05 inapita. Vizuri sana. Okay. So you'll go to the next one, which is 0.1. You try 0.1 millimeters. It will still pass through that gap. So it tells you that the thickness of that gap, okay, is more than 0.1 millimeter. So you'll try 0.15. So unaenda tu ukiongeza mpaka ile ambayo itakataa kupita. So say for example 0.05 imepita that gap, 0.1 ikapita. Now 0.15 haikupita. So which means the gap is between 0.1 millimeters and 0.15. And because there is none in between, you always approximate it to the last one. You always approximate the thickness to 0.1 millimeters. Now, so you can check it all along. Kama for example, even at 0.4, so unaweza kuja, kama for example, na check hapa, okay? Una check hapa mahali nimesema, na pia unaenda pale mwisho. Okay, those could be the 3 points. And then you also place the straight edge again diagonally like this. So una check hapo, maybe ukuja ucheck hapa, na maybe hapa. Something like that. Okay? So and then you keep recording. Okay? You keep recording. Now you can now be able to to now tell in terms of all those gaps, could there be those gaps, are they within acceptable limits? Could they be covered by placing the gasket, or can the gasket do a sufficient job in, for example, maintaining the compression in the engine or preventing any leakage of both the gases or even the oil that is inside? All right. So you simply also compare it with what? With the manufacturer's manuals. And like I said, if you go to a proper workshop, they'd be able to know. They always know what is between, and even for different types of engines. Because they also, as you same for all types of engines, you'll find that for different kinds of engines, there are certain limits or certain tolerances. Okay? Around, above which you should not go. Okay? Ukipita, for example, if, for example, it fails a flatness test, maybe your engine block fails a flatness test, what do you do with it? Okay? What do you do with it? Do you go and do some facing operations on it to impart some uniform flatness? All right? Those are the questions. If it is a cylinder block, and you go and do some facing operations in order to impart a uniform flatness, do you need to replace it? Those are the kind of decisions. So I want you to now tell me what is the purpose and what are the corrective actions. So the corrective actions, of course, are based on the results, what you do normally do in certain cases. And those are the things that I want you to tell me and go and read for yourselves. Now, I also move forward. Nimetoka hapo nikaenda piston. So kwa piston, these are the same things ambayo nilikuwa nimewaelezea. You can take measurements up and down. For example, hii, kama this one is measuring the skirt, okay, the skirt of the piston, okay. This height, you can check this height, okay. You can always check that height. If there is anywhere on the top part of the piston hapa, then he measurements, you can call it H, itapungua over time. Okay, so if there is where, because remember that at the top I say that there is what? There is a combustion processes that are happening, and always happening at a very high pressure. First of all, the piston is moving at high speed, all right, and always carrying with it high pressures and temperatures. All right, like I said, fuel will have some small level of corrosion one way or the other, but they could wear out some the piston. It depends on the material your piston, because also different manufacturers automate different materials and different methods of alloying, for instance. All right, so you always kind of check those kinds of measurements. And you can also measure kama hii, for example, nilikuwa nimesema ovality is A minus B. Kama hii, for example, this is ovality. And then you can create a table like this. You can see this table. So kwa hii table, you can see these are different types of engine. Kwa engine ya kwanza, mineral, diesel oil, linear biodiesel. You can always use them. Okay. And by the way, this kind of measurements can also be used to test the efficacy of certain types of fuels or certain types of configuration, engine configurations as well. Okay, especially when a manufacturer would like maybe to improve maybe the certain configurations in terms of the engine, because kila engine hukuja na technology yake. So these are the kind of measurements that they normally use in order to get the correct data for the purpose of maybe redesigning the engine, for example. They usually do these kinds of measurements, and they have to test the engine over a long period of time, and then they get the data. Sometimes even we draw engines from the market that have been functioning normally, and then they go and do those measurements, and then they can be able to determine the degree of wear, for example, in order to determine whether maybe the materials they used are working fine, the kind of alloying processes are working fine, the kind of machining processes that they used are okay, right? And then they can use that data to do any kind of redesign. So some of these measurements are not only for engine maintenance or servicing. Sometimes there are even data that are live data that are used by manufacturers. Okay. Think of, for example, I've been very excited with the Artemis mission, ile ambayo we've sent some people to cycle the moon and coming back. Okay. That was a test flight. All right. Some people were saying, why is it not landing at the moon? Okay. You don't know the purpose why it was sent there in the first place. It's to collect data. That scientific data is very important. They're collecting scientific data in terms of the performance. Even the capsule that will be coming and entering the Earth's atmosphere in a ball of fire, sometimes at around 3 a.m. today, they'll go and put it somewhere and carry out a lot of scientific measurements on it to see how much it withstood. Is it possible to redesign, say, for example, the heat shield, all right? Because in the first one, that is Artemis one, they found that parts of the heat shield did not wear out the way they were supposed to be. They were wearing out non-uniformly. Some parts are simply chipping off. And then they went and used that data to redesign it. Now you have human people on board. They're also going to check it. In the next mission, they will always improve it. And that is the work in an industry, ya watu wanaitwa R&D engineers. Okay? Research and development engineers. So the work of these people is to constantly carry out or collect the data from even ordinary functioning, proper functioning vehicles. Not for the sake of maintenance, but for the simple reason that they would like to do some improvements on some of the processes. Now, the other one hapo ni camshaft. Okay? So nilikuwa nimeshasema camshaft. I think nilikuwa so hii unaweza pima direct na vernier. So kwa camshaft unapima tu, so for the camshaft unapima the cam itself, of course. You measure the cam, and then you can also be able to check for the degree of wear. Remember, what causes wear between the cam, in the cam, is that they are always in contact with the follower. In this case, it could be the push rod, which I had already showed you, or sometimes they are just in direct contact with the valve when we talk about the overhead cam arrangement. Okay, so which means there is relative movement between either the follower or the valve itself. There'll always be some wear. So you always want to also monitor that kind of wear. And but of course, they always design these things to have a very long life. Okay, you can even use it for up to 15 years without getting considerable wear, depending on the engineering that was put in it. But all I'm saying is that, you can never know. From time to time, you'd find that these kind of measurements are usually necessary, also in terms of making decisions on whether to replace it or not. Now, cam characteristics. So nilikuwa nimesema, for example, the difference between nilikuwa nimesema this is the base cycle, the difference between here, okay, here na the whole of it. The whole of it ndio inakupatia valve lift. So this is a valve lift. All right. So it can be able to give you the value of the valve lift is very important in terms of determining how fast and how tight the valve closes closes. Say, for example, the intake manifold or the exhaust manifold. All right. The efficiency. So sometimes, if, for example, the valve lift is too much, it means that the closing or the closing of the intake manifold could delay a little bit more than would be necessary. If there's a delay, it will affect the amount of power produced at the end of the power stroke. All right. So it is very important, especially in terms of optimizing power production. Too much or too little of it can easily mess up with fuel efficiency of the engine. And not just fuel efficiency, the thermal efficiency, which of course is connected to fuel efficiency, volumetric efficiency. Yes, mostly for volumetric efficiency and thermal efficiency. Okay, mostly those two are the ones that are mostly affected. Now, then tuko na hii. Okay, so tumemaliza the engine measurements. So I just want to talk about very quickly about things like engine servicing and maintenance. So for engine servicing, I'm sure most of you would have someone way or the other dealt with this. So kwa vitu kama engine service, I just wanted to add it just to talk about it generally. But kwa engine, you always want to watch out for oil filters. Okay, oil filters do a lot of work, and the difference between a new and a worn out can be as bad as that. You can see the worn out one here, the one on the left. Okay, it's totally worn out. Yeah, the oil is just in a bad state. It's totally worn out. It will never function as it's intended. It also gets clogged with time because of the fact that, like I said, sometimes you have particles of the air. Okay, when the engine is inhaling air, if the air filter is not very good, it could let in some particles. When those particles are combusted, could be very, very tiny particles, but when they collect over time, those particles could become big enough, and during the combustion process, they are left as deposits on the edges of the cylinder, and they could end up in circulation inside the oil. All right. When they end up in circulation, those are the kind of particles that you do not need in places that have high rotation. So if they meet, for example, if they log themselves, they are lodged inside, for example, bearings, then you know they're going to cause a problem. So anytime the oil is circulating, it will always pass through the oil filter. Okay, it will always pass through the oil filter. The oil filter will collect all those particles that are not needed, and they could come into the engine. They can be introduced in very many different ways. Okay, now, so you can see here, so you normally, first of all, you normally check. So what this guy is holding is known as a dipstick. Now dipstick inakuanga na two parts. So dipstick inakuanga na a high and low. Okay, inakuanga na high and low. For example, you can see that there is a small hole right here and another one down here. Okay, now those two are an indication of high. Okay, kuna high na kuna low. Okay, so usually you target to have the oil ikikuja mpaka hii high. So this is H. Okay, well, this is L. So if I kupita H, if I kuja chini ya L. Now, what is the problem with ikipita H? Ikipita H, okay, then it means that you have an oversupply of the oil. If there's too much oil in the process of circulation, when the pressure builds up, sometimes it cannot be contained within the engine. So you have too much of it in circulation that would be necessary. So it could cause, for example, some of it could constantly leak onto the combustion chamber. And you'll always have problems with combustion processes. To always cause problems with combustion processes. So you don't want excessive oil. It's not a good thing. Just because you have a lot of oil does not mean a good thing. Okay? You'll have too much of it in circulation and it could easily leak inside the cylinder. And then you're going to have problems with the combustion process, because if you are having oil mixing actively with fuel, then you'll have very poor thermal efficiency of the fuel itself. You're not able to extract that is the right amount of energy or the correct amount of energy. And then again, some of it could end up even attempting to leak through the surfaces, where, for example, through where you have the gasket placed. So it also places undue pressure in the gasket, which is also it's not a very ideal situation. Now, ikikuja chini yake kama hii, for example, hii inafaa kutop up. Okay? Hii unafaa kutop up because unaona iko chini yake. But ikiwa anywhere between H and L, hata hapo, bado ni sawa. Hata ikiwa hapo bado ni sawa, ikiwa hapo bado ni sawa. So anywhere in between is fine. Okay, but I always attempt to always go towards the upper limit, because sometimes you also do lose some bit of it. Okay, kuna kuwa na times tu yenye the oil itself within the engine will always get used up somehow because of the processes that are happening, the temperature, pressure. Sometimes it could also be some minor leakage which could go undetected. So, and some of those minor leakages may not be detected maybe over a period of some small periods of time, especially for example, kama leakage haija build up to where you can notice it. Sometimes iko tu just kidogo tu ina leak. So to cover up for that, I always want to feel to the upper limit. I mean, it's not a requirement, but I always want to go for the upper limit, but not beyond that. So the second one requires topping up. Hii hapa ina require kutop up. Na hii ingine, even though it is within the same limit, unaona iko within, this is H, this is L. So it is within the correct limit, but look at the color of the oil. Okay, ukiona hiyo color inamaanisha there is something wrong. Now that is oil that is already spent or worn out. Now oil degrades over time. The specific composition of oil, be it natural oil, semi-synthetic, fully synthetic oil, lazima ina degrade over time. Why? Kwa sababu nilisema it functions in an environment there is always high temperature and pressure. So it will always break down. Remember, these are hydrocarbon chains. Okay? And remember, hii oil, especially the natural one, is normally obtained from refining of crude oil. So when you refine crude oil, you always get different types of like fuel. For example, utakuwa na kerosene, uko na jet fuel, utapata petrol, utapata diesel. And then it continues becoming heavier and heavier going down. So mpaka hata unapata heavy diesel oil, unapata taa, ile nini, vitu kama hizo. Then you also get this kind of oil. So it will break down because of the fact that it is primarily made of organic matter. But even for synthetic oil, which is made up of a lot of artificial kinds of materials and all that, I mean, the building blocks are normally artificial. They will still break down because of the fact that they will still obey the chemical processes that are used to build them. Okay, so whatever holds them together will always break them down. When they break down, they will lose their ability to carry heat. Like I said, they're supposed to be carrying some amount of it, and they'll also lose their ability to lubricate. When they lose their ability to lubricate, that happens, then it could expose your engine to oil starvation, where you're not having sufficient lubrication, especially at the moving parts. So that's why kuna kungana certain kind of mileages ambayo unatumikanga kufanya nini, ku determine when you should do the oil change, depending on whether it's synthetic, semi-synthetic, or natural. Okay, so you normally place the dipstick like that, in that manner, just to check the level of the oil. Okay, now the other thing that you should also know is when doing the oil change, the first thing is that you always open an oil cap. Oil cap inakonga pale juu kwa, if this is the cylinder, sorry, this is the engine. Okay, so the lower part of the engine iko hivyo. So pale juu kuna kuanga na oil cap. Okay, so oil cap inakonga hapa juu. So you always open the oil cap. Okay, and then kuna kuanga na drain plug here. Mostly it's just kuna kuanga hapa chini. So mostly the drain plug inakuanga tu, it could be just a very simple, I mean, it could be a nut, okay, a special type of a bolt, okay. It's a nut and with some section that is protruding inward with external threads that can easily be placed by screwing it onto the oil sump. So this is the oil sump, yeah, pachini. That is the oil sump of the crankcase. Okay, so you always have to open the top part so that when you drain your oil, that is the oil cap, pale juu, so that when you drain your oil, so this one here is the cylinder head. Let me just mention, well, this is the engine block. Just a minute, just a minute. sorry for that. Okay, so I was saying, so what you're looking at, what I've sketched is a very simple illustration. Na nimesema here juu, you can take it as a cylinder head. This is the cylinder block. This is the crankcase. Okay, I'm just sketching it. So you always have to open the oil cap, like I said, iko hapo juu. Then you fungua. So you are going to, so you can use a spanner. Okay, you can use a spanner. They can be different sizes. Then you open the drain plug. The drain plug will allow the oil to flow smoothly with the aid of atmospheric pressure. Usipofungua ile oil cap iko pale juu, then yes, you'll have some oil draining, but not all of it is going to drain out, because some of it will be held by the atmospheric pressure that will be going inside. The atmospheric pressure will act on the oil from the lower side, and it's going to prevent most of the oil from coming out. Okay, so lazima unaiacha drain kabisa kabisa. Once you've done that, then you can always so once you've removed once everything has drained out, what you normally do is that you also have to untighten the oil filter. So oil filter inakuanga ndio hii. So oil filter usually over time inajitighten yenyewe, okay, because of, like I said, the action of pressure and temperature and all that. So it becomes a little bit tight. So kuna zingine ideally unafaa kuweza kufungua na mkono. Okay, because if you see the lower part of the oil of the oil filter, you can see here that it is not perfectly smooth. Okay, so there's some sort of a polygon shape below it that allows for sufficient grip. So unaweza kushika na mkono na uifungue, but some of them are not easy to access. You see, for example, some of these German machines, they're not in places that can easily be accessed. So in that case, if you cannot easily access or uwezi uka tighten na mkono, you can use an oil filter wrench. So an oil filter wrench ni hii. Okay, so an oil filter wrench inaweza kuwa on one end there's a handle. You can see there's a handle, and then on the other end hii ingine that grips now the oil filter, it could be some it looks like some sort of ni kama a belt or something like that, that will grip it very tightly, and then unaweza ukaifungua kirahisi. But sometimes it's also a chain. Sometimes ni kama kale kanyororo. Kuna zingine inakaa kama ile nyororo ya baiskeli, so it will really grip it. Okay, the problem na hiyo nyororo ya baiskeli, sometimes it will just eat into the oil filter and all that, and but anyway, it still doesn't matter, because once umeitoa oil filter si kitu ya kuirudisha, especially once you are doing oil service, oil change. Okay, but the oil filter wrench is usually it makes your work very easy. But if you don't have it, then you'll be ready to have a very strong hand and maybe some cloth to ensure that you remove the oiliness of the surface of the oil filter and uweze ukaifungua. Now, that is when untightening it for the purpose of removal. But when tightening it now, because once umeitoa, you'll also allow some oil to drain from it, because by the way, once ukitoa hii, you'll also see some oil draining from the oil filter. So you'll have to allow some oil to drain out. Okay, to allow it to drain out. Then after some time, you first of all replace the new one. Naeka ile mpya. Okay. Now ile mpya, it is not a very good idea to tighten it using the oil wrench. Okay. It's not a very good idea. Why? Because sometimes when it grip it like this, unaona vile unaigrip hapa, the way you are gripping it like this, it can easily damage the oil the oil filter. Kama bado iko mpya. You can see for this one, this guy attempted to tighten it using an oil filter wrench, and especially the worst ones ni zile ziko na instead of maybe a belt material hapa, iko na nyororo. Hiyo nyororo itaikula yote hapa. You can see, for example, here it will cause some dents on the parts of the oil filter. Okay, it will cause dents, and those dents are already structural weaknesses on the oil filter. Under very high pressure, oil could easily leak from these places because of the structural weaknesses that are created. So kwa kutighten, inakuanga ni mzuri kutighten na mkono. Okay, you always taught to tighten it with your hand. So oil filters are supposed to be hand tightened. Even if you see what the most manufacturers would always or even servicemen or repairmen, they always advise you to tighten it na mkono. You can just use some piece of cloth, kunakuwa na ile cotton waste, inakuwa a lot of it kwa workshop. just ensure that you get a tight grip on it, and then you tighten it na mkono mpaka uone iko very very tight. And of course, usually the first few days as the owner wants to umebadilisha, you always check whether there is some level of maybe leakage. Okay, but once you tighten it properly, utakuwa na shida yote. Just tighten it properly. And you can also, another thing that you always advise to do before even changing the oil filter is that you always apply some thin film of oil on the mating surface between the oil filter itself and the cylinder block, okay, to allow for a proper sealing, because at the mouth of the oil filter kuna a rubber seal, all right? There's always a rubber seal, all right? So it creates so you always apply some thin film of oil around the mouth of the oil filter. So and then also the surface of the oil engine block where you're going to place your oil filter, and then now you can tighten it with the hand. Okay, so you can see this guy, for example, this guy is tightening it by the hand. That picture there, the lower right side of the of your slides, you can see that guy is tightening by hand. So inafaa kufungwa hivyo na mkono. Okay, inafaa kuwa tighten na mkono. You never use the oil wrench. You can easily damage it before you use it. Now, so another thing is, I just want to move on, is what we will always look out for, gaskets. So you'll always see things like blown gaskets, for instance, kama hii. You can see this one is a blown gasket, and you can see it wears out. Okay, these are gasket. Unaona hapa vile inaharibika. Kama hii kabisa imeisha. This one is a blown gasket. So blown gaskets, what is the cause? Okay, nataka muniambie. Okay, what is the cause? All right. Yeah, so what is the cause of the blown gasket? What causes it to blow out? What causes it to wear out in this match? Nataka muniambie. But you can see the difference between a new one and an old one. Okay, somebody can type hapo kwa nini hapo, what can cause these kinds of problems? A blown gasket, what causes it? Yeah. So, but generally, blown gasket is something that is supposed to be replaced, because like I said, it causes a myriad of problems. One is loss of compression. The other one can also cause leakage at the surface between the engine block and the oil sump, or the oil reservoir, or the engine block and the engine head. Okay, you can see the new one, how it looks like, yeah, and then compare to the blown one. So those are the things I want you to tell me. How do you, what are you looking out for when you talk about a blown gasket and all that? Okay, or what causes a blown gasket and what are the problems associated with it? Okay, the other one is air filter. So air filter, like I said, in a letter, this is the engine breathes through the air filter. You always have an air filter to ensure that you are replacing, to ensure that there is a clean air that is going into the engine for the purpose of combustion. Okay, remember, for example, if you are going through a terrain that has a lot of dust, if that dust gets into the engine, then you're going to choke the engine. All right, choking the engine basically means that in addition to the air and fuel that you're combusting, you also have some dust particles that do not participate in the combustion process. So if they're not participating in the combustion process, it's like carrying a baggage ambayo haikusaidii mahali. Okay, can you imagine, for example, you're going for a journey and kuna vitu umeweka kwa mgongo, na kwa hiyo vitu umeweka kwa hiyo mgongo ni mawe, na hizo mawe hakuna mahali unaenda kuitumia au uitumii chochote. So it's just wearing you down. Utachoka tu bure na hakuna kitu unaenda kuifanyia. So think about the same thing. It's some sort of an extra baggage for the engine that is not useful in any way. And those are the kind of things that causes the engine to have less thermal efficiency, that is reduced thermal efficiency. So it's not able to extract as much the amount of energy in the fuel that is required. All right. So it's a problem. You don't want that. So air filters are supposed to be replaced. And like I said, I think I mentioned it last time here, that you replace them. You can replace them together with replacement of the oil. Do you know why? The reason why they are normally associated with replacement together is because when you do go for a service, unazifanya tu pamoja, just replace them. However, I think nilikuwa nimesema that hazina uhusiano wote. Okay? The air filter can be replaced as numerous times as possible without even, because for example, if you are operating in a very dusty environment, you can replace the air filter even 3 times before you replace the oil and the oil filter. All right? Because this one ndio inadetermine ile air inaingia pale ndani. Okay? Somebody talked about overheating. I don't know what overheating is inamaanisha hapo. Oh yes. Victor Mutugi, yes, you are right. What can cause problems with the gasket? I know you're referring to, yes, overheating of the engine. Now, what can cause overheating of the engine? For example, if there is no coolant, sufficient amount of coolant in the engine, for example, it overheat, right? Or if there is unregulated temperature, kuna konga na kitu fulani pale kwa engine, thermostat, kuna thermal sensors pale ndani, okay, that are supposed to, for example, if there is the coolant, kuna konga na coolant temperature sensor, and the coolant temperature sensor always ensures that if the correct, yes, thermostat, naona Lumuria Moses, asante sana. So the thermostat, if it also fails, it's unable to signal the engine to cool or to cool the coolant faster, and the coolant is cooled much faster using techniques such as what? For example, you cool the engine using the fan. So kuna kind like a coolant fan that usually comes on when the coolant itself has started to overheat. So the coolant simply aids in the process of cooling. So if the thermostat has failed, then the cooling fan is not able to come on, which means that the coolant will remain in a higher temperature, and it's not. And if it is in a higher temperature, the rate of heat transfer between the engine block and the coolant is going to be much less, which means that it will allow the engine to overheat. These kinds of overheating over time causes these kinds of problems with the gasket. Thank you for that, Lumuria and Victor. Asante. So now I want to move to Niliko hapa. So you can see, for example, a worn out. In fact, this one is not just worn out. This one is a clogged. Block. This one has block. The one below here is good. Huyu jamaa mwenye ameshika na orange hands, or orange gloves. This one is still working, looks fine. But here juu, this one is clogged. Clogged inakuwa na, I mean, the clogged air filters are these ones will cause a serious problem with fuel efficiency. You know why? Because it messes with what you call the air-fuel ratio. Okay, there's something called the air-fuel ratio. Tutaiongelelea the air-fuel ratio. Pia kuna engine knock, improper installation. So yes, engine knock. So Francis Kioka ameongea kuhusu engine knock. So engine knock is where you have so engine knock is normally caused by improper air-fuel ratio or improper compression. That is the compression ratio, or the engine unable to attain certain compression ratios that are associated with this. For example, when you talk about petrol engines, for instance, the compression ratio do not usually exceed 10 parts of air to 1 part of fuel. Okay, no, sorry, not 10 parts of, that is air fuel ratio. That is the ratio between the what we call clearance volume, that is the volume of the combustion chamber, and the swept volume, that is the volume of the cylinder. Okay, so that ratio is very important, the compression ratio. If it is exceeded, for example, then it can cause premature or improper detonation of the fuel inside. That improper detonation can also cause the type of problem that you are seeing there with the gasket. So you guys are right. Improper installation, yes. So if, for example, the installation process is also not good, then one part of the gasket could be exposed too much to the amount of heat that is being produced during the combustion process. So yes, I think early detonation of the air-fuel mixture, yes, that is what causes engine knock. Lomuria, that's what causes engine knock. Now, so the other thing is we also have something that I've also observed. Kuna kugana ile, and maybe for those of you who've done a lot of work with engine repair and all that, kuna kugana whenever they are replacing these gaskets and all, sometimes wanekangana a silicone sealant around the surface, okay, between the engine block and the engine head. Yeah, so I want you to tell me whether the use of silicone is usually, I know maybe it's for effective sealing and all that when replacement is done, but sometimes it's also placed incorrectly. Some of the silicone, whenever you now tighten because you normally tighten the engine head onto the engine block, some of it, the silicone will spill onto the inside of the engine, of the cylinder. What happens to that to that silicone that spills inside? Because what kind of care do these people who normally do this kind of replacement take to ensure that none of it actually ends up in the cylinder? And when it ends up in the cylinder, how do you get rid of it? Okay, so that's the kind of questions that I really want to ask, like, where would it end up finally? Hiyo silicon itaenda wapi finally? Those are the kind of questions I always ask. High engine pressure, yes. Overloading, yeah. So high engine pressure is so kuna kwanga na pressure sensors inside the engine that always configure the engine pressure according to what the ECU requires, especially for the very modern engines that have very high level of where the ECU has a high level of control in terms of the engine as well, in terms of the engine functioning and optimizing all the processes within the engine, especially the combustion processes. Yeah. So if the engine pressure is also that goes unchecked, the engine pressure inakuwa caused especially by the compression ratio. So the compression ratio always has to be regulated, especially by the ECU. Okay. So when there's also a non-regulation of that pressure, because kuna pressure sensors inside that always look at the optimum in-cylinder pressures, especially during combustion processes. Okay, so if there's a regulator, yes, I agree, it can also cause that kind of problem. So anyway, with the air filters, nimesema they can cause loss of air fuel efficiency kwa sababu ya these kinds of problems. So they should always be replaced as often as possible. Na mimi nimemaliza hapo. So ningetaka maybe kusikiza swali kabla niende something else. We still have at least some, I could still do so for some minutes before I go to maybe something else. Nataka kusikiza kama kuna swali lolote kabla niendelee. You can type if you want, so you can ask directly. So I could give like maybe some 3 minutes kama kuna swali, and then I'll just see what I can answer, and then we'll proceed. Christopher, I was asking kwa silicone, between this is the engine head, okay, including the cover and all that, and then this here is the block. This is the engine block, okay, and then finally here maybe you have this is where you have your oil sump. So hapa ndio unaekanga you normally place your gasket, but I've also seen quite a number of people use silicone as a sealant hapa, especially when they're replacing the gasket for one reason or the other. Naonanga wanaeka silicone, so some of that silicone when you just place it before you tighten it, the moment you tighten, some of the silicone, of course, because it's, I don't know, is it liquid or plasma? I don't know whether is it liquid or semi-solid. So the moment you tighten it, then some of it they will always spill out because they stretch out. That's matter when you apply pressure on it. They'll always stretch out. So some of it will stretch out na inabaki ndani ya engine, ingine itatoka nje. You'll also see it even, hata saa zingine unaipanguza unaitoa some bits of it kwa along where the gasket is, hapo tu kwa nje. So kuna ile ambayo itabaki ndani. Okay, what happens to hiyo silicone ambayo inaingia pale ndani? Yeah, so I don't know the justification of using silicone, because the moment you press it, or what kind of guard or necessary actions do the mechanics, for those of you who know, take it to ensure that once they put in that silicone, it does not spill onto the inside of the cylinder? Okay, hiyo tu ndio ilikuwa ni swali yangu. I'm just curious to know for those some of you wenye wamedeal na these mechanics. Yeah. So now, so I'm back now. So John Kennedy amesema, yeah, you put a minimal amount, okay. Yeah, so which means the care has to be taken, or instead of silicone, you apply oil in the gasket, okay. That's fine. Muria Moses amesema, spark plugs will misfire and valves will have poor sealing over time. So they'll burn with the fuel, but you can't burn as fuel does. Okay, all right. So because of the pressure and temperature inside, they will eventually sort of burn. So over time, they will just eventually finally burn out, and then they'll just come out as part of smoke. Okay, that's fine. But it definitely means that if, for example, somebody raise your hand, Patrick, yeah, you may proceed to speak, Patrick, if you would like to say something. They just proceed and speak, Patrick.
Based on that last explanation, how will the silicone get into the combustion chamber?
How will the silicone get into the combustion chamber? Okay, thank you. So, Lemuria, Moses, are you able to answer that? Moses, if you are there. Okay, so I don't know whether it's there. But so look, the thing is, this is the engine. Okay, kuna hii diagram nilikuwa nimechora hapa. So you see the cylinder ni kitu tu kama hii, just a hole inside the block that goes from top to bottom. And then on the cylinder head hapa unakuanga na a small part that protrudes slightly upward. If we are talking about a spark ignition engine, hapa kutakuwa na spark plug which will protrude kidogo tu hapa ndani. Okay? Also kama kuna valve. Okay? Kama kuna any valve. Okay, if you have a valve here. Okay, maybe I could let me just expand here. So this is the cylinder head. Okay, that is the cylinder head. That is the cylinder block. Okay, that is the cylinder block. Because there's a sealing in between, hapa ndio unaweka between the cylinder block and the cylinder head, utaweka gasket hapo. It's something that is flat. Now, where you have the cylinder, which is as a hole, inside of here utapata kuna slight protrusion upwards on the cylinder head. Okay. Now kwa hapa kwa cylinder head utapata kuna vitu kadhaa. This is hii inaitwa valve. So hiyo ni valve. Then there's also another valve. Okay. So hiyo valve ya kwanza ni intake. We can call it the intake valve depending on the orientation of the engine. And then this is an exhaust valve. Okay. There's an exhaust valve. And then if this is a spark ignition engine, utakuwa na a spark plug. And then the rest of the spark plug will be protruding in upper. So hizo vitu zote ziko hapa ndani. Hii chamber ya hapa juu ndio inaitwa combustion chamber. So you see here, if the silicone imewekwa hapa, lining hapa, and part of it is protruding somehow, I mean imebaki pale ndani. When the combustion process starts, the piston inside here, kuna na piston hapa, piston ndio inakuanga hapa, and then you have the connecting rod. Okay? So the piston is always moving up and down. So if parts of that silicone falls hapa, when the piston moves to the TDC at this point, then some of this silicone could be deposited right at the top here where the combustion chamber is. That is how the silicone gets into the combustion chamber. The moment it ends up in the cylinder, it will end up in the combustion chamber. Yes, Moses, proceed. Moses.
Oh.
Yes, Moses, proceed. Okay, maybe Moses amesema ako na shida na sauti. So I hope I've answered your question. Ilikuwa ni nani ameuliza hiyo swali? Nimesahau ilikuwa ni nani, but I hope I've answered your question. Okay. So, sijui kama kuna swali lingine. Yes, Mamuria. You can as well type. Kama uko na shida na audio, you can as well type. Okay, so I think I'm done with that. I would not want to go beyond that so that we can also have sufficient time to discuss something else. So in case I have not answered, ama kama kuna bado kuna swali lingine, just ask. You can as well just type. Nitajibu tu. I'll not skip any question. So please, you may just, you're free to keep asking any additional questions as I upload a new PPT. So kwa hii PPT nataka kuipitia haraka kwa sababu it's nothing very complex. It's a very, very short topic. A very short topic ambayo inaitwa so it's a very short topic and I'm intending to finish it in the next say 30 minutes or slightly more, maybe 45 minutes ikienda sana. Okay, so here Moses, I'm proceeding on. That is where we are. So the braking system. So braking system haina mambo mingi. So I know most of you already are aware. So I'll just talk about most of the things were not mentioned. I just want to talk about just a few things, a few pointers for braking system. Because there are some other things we need to learn. There means the calculations which tutazifanya kesho. Hopefully we can do them tomorrow. So kwa this one, kwa sababu ina story mingi, nitazipitia tu. So I think all of you know the work of a braking system. So the work of a braking system is so it helps with the control of the vehicle. Braking system allows you to have a certain degree of control of the vehicle. And in conjunction with the steering system, unakuanga na, in conjunction with the steering system, unaitumia the braking system alongside the steering system to control the vehicle. Without the braking system, you are not able to control your vehicle. Okay? Now, so kuna kuanga na different types. Okay? So you can go and read about the hydraulic type. Okay? The hydraulic braking types. Okay? You can go and check the pneumatic type. Okay? Kuna mechanical types. Okay? Kuna electromechanical type. Or usually, yes, electromagnetic type. Okay, so ziko mingi. There are so many types of braking systems ambazo we will you find them. So you go and read what you have in the notes in addition to other things. Now, so for hydraulic types, there are two main categories under hydraulic types. Two main, not categories, but systems that are normally used for hydraulic braking. Okay, one is known as the disc brakes, and then the second one is known as the drum brakes. Okay, so drum brakes ni easy, so I'm sure you've seen them. So disc brakes zinakuanga, so you normally have here uko na a brake pedal, then a brake booster, and then a master cylinder. And then you go inside hapa kuna slave cylinder, a small cylinder. So a slave cylinder ndio hii, it's in red. Maybe I could use a different pencil to point out hapa. Okay, so you can see here it is in purple, this one here. There's a slave cylinder. So it always moves sequentially. You apply the brake pedal, it goes to the brake booster, then it goes to the master cylinder, and then there's a single master cylinder which will now distribute it to the four slave cylinders in kama gari kona migune. Okay, you have like 4 main driving wheels, then it will go to all the 4 of them because each of them will have a slave cylinder. Okay, now there's something first of all I want to speak about before I go to anything else. The brake booster. How does the brake booster work? Okay, so brake booster, I think, let me see if I have something here shown kwa brake booster. Let me see kama niko na brake booster mahali. Yes, ndio hii. So now brake booster, I'm sure most of you mumeona brake booster, but sometimes you may not notice it, especially if you're not keen or you would not really want to know what it is all about. So the brake booster is a way of multiplying the force supplied by the driver, and it's a very ingenious technology that was invented in order to ensure that you do not need to keep applying onto your foot all the pressure that is required to bring the car to a stop. Okay, so just a way of assisting you, kind of like if you think about the steering system, kuna kuanga na power assisted steering system. Okay, there's usually a power assisted steering system. So to help you to multiply your effort, your steering system, unakuanga na power steering system. Now the same thing, brake boosters work in an almost similar way. All right. Now, so how does it work? And this one is very, very simple. I don't want you to overcomplicate this. It works in a very simple way. One, kuna brake pedal ambayo wewe kama driver unafanyanga nini? Unaikanyaga. Okay? Unaikanyaga kama dereva. Na ukisha kanyaga, it is pivoted about this point hapa. Okay? Ushajua hiyo. Now, one other thing you should know is that hapa kuna kuanga na, unaona hiyo na hii ni the same thing. We call that a reservoir. So that is a reservoir for the brake fluid. And by the way, brake fluid is some type of an oil. Okay, some type of hydraulic oil, but specially made to work as a brake fluid. All right, the different kinds of environments and all that. So it's just specially made to work as a brake fluid, just for efficient transfer of force. All right. Now, so hiyo reservoir ndio ile unaifungwanga pale kwa this one you can easily access it from the under the hood. Ukifungua kale ka bonnet ka gari pale mbele, you can always easily access it. Na hapa juu you'd usually see a symbol like this. Utaona ka symbol kama hii. Okay, something like that. Ukiona symbol inamaanisha ni ya brake fluid. All right, so that usijipate umeka coolant hapo ndani. Ngoja umejaza coolant hapo ndani alafu na kanyaga gari unaenda alafu unaanza kupata mashida hapo mbele. Nashindo, what is happening? Hii gari is not responding to anything because you've used it. So inakuanga ni mzuri kujua there are quite a number of them. Kuna kwa pia na power steering fluid, lakini the good thing is that even usually kuna kwa na color coding. Utapata kama coolant for example, coolant utapata color coding yake inakuanga ni blue. Okay, sometimes red. Utapata pia power steering liquid inakuanga na different kwa hydraulic type. Unajua kuna kwa power steering za hydraulic na zingine za electrical. Zingine electrical ni zingine ni electrohydraulic anyway, but mostly kama unatumia hydraulic power steering system pia ina kuna color code yake. Nimesahau ni gani, what is the color code? Kama mwenye anajua hebu just niandike color code ya power steering liquid. Inakuwa reddish, is it more or less like reddish brown ama nini? I don't know the color. Somebody just type it up. Now pia hii ya brake fluid inakuanga clear. I think the color is what? Is it clear? You can call it clear or what? Or you can call it, I don't know the color as well. Do you call it clear or something like that? So you can color coding so that you do not mix them up. So inakuanga ni mzuri kama unabadilisha some of these fluids inside, or you're flushing or draining. It's always good to know the color code represents what. And most cars these days attempt to use the similar color coding for the sake of universality. Just like squeeze uko na karibu simu zote ziko na almost the same type of charger. So for the sake of universality. Anyway, so let's proceed. Now, so hapa unaona hapa brake effort inakuja hapa. Okay? Braking effort iko hapa. And then chini yake hapa ndio kuna master cylinder. All right? So the whole of this hapa is the brake booster. Now, let's see what happens. Now, kitu ya kwanza unafaa kujua ni hii. Kabla tuendelee, this brake booster iko na two chambers. Iko na the right hand side and the left hand side chamber, and then it is separated by a thin material. Unaona this thin material hapa, it is known as a diaphragm. Jua kwanza kuna two chambers. Tuanzie hapo. Now, the next thing is that the right-hand side chamber, this one, is filled with vacuum. Okay? Kuna vacuum. What is vacuum? Negative pressure. So, negative pressure can be supplied from the engine. See, for example, when the engine is moving down during intake stroke, it normally creates a negative pressure inside the engine. That negative pressure can be tapped and then rerouted to the brake booster. That's one of the technologies. But the other technology is to have a pump, okay, that creates negative pressure and then pumps it inside the right-hand side of the brake booster. Okay, so kuna different technologies. You go and read about the different ways in which negative pressure is created here. But there are so many ways of creating negative pressure. All right? So just absence of air is vacuum. Tuko sawa hadi hapo. Now the next thing is this. Once you have the vacuum, on the left hand side hapa, you have some minimal amount of air. Okay, not so much, but air that is almost the same pressure with the vacuum. Okay, so you have air that is almost the same. The pressure of the air on this side here is almost the same as the pressure here. Okay, now the next thing is this. When you press the brake pedal, now I want us to go to the mechanism. When you press the brake pedal here, I said that it is pivoted above this point. So there is a push rod here. Okay, so this push rod pushes now. So there are two things. So it will push. Can you see here that there's a valve. I can't see it here. Haijaandikwa hapa, but kuna kwanga na valve somewhere here. Okay, and here it's called a poppet valve. Okay, so the poppet valve, and then the green part is a part of a piston. Okay, so it's a valve. So that is a valve. Okay, so we call it a valve piston, the green part. So on either side, at the top and the bottom, they are poppet valves, and then the green one is known as a valve piston. I think they have not written here, but it's normally called a valve piston. And then kunakuwa na hii kitu inaitwa reaction disc, which is in purple. Okay, pay attention to those things. So when you apply the brake pedal, it pushes the push rod inside. Now the push rod inside, the moment it moves, this one here, the moment it moves slightly away, it will let in atmospheric air inside this left-hand side of the chamber. Now, once it lets in atmospheric pressure, the difference in air pressure, okay, the difference in air pressure between the left-hand side where you have atmospheric pressure, the difference in air pressure, the value of pressure between where you have atmospheric pressure and where you have negative pressure will be so big. All right. The other option would be to have atmospheric pressure on this side, and then on this side you pressurize. Okay, you'd have to pressurize so that you have a more difference in terms of atmospheric. But if you introduce vacuum on this side and you introduce normal atmospheric pressure here, the pressure difference would still be very high. So all you are going after is the pressure difference, not the value of the pressures on either side. You simply create a wide pressure difference. When you have a very wide air pressure difference, because there will be very little pressure here and very high pressure here, that very high pressure will be pressing so hard on this left-hand side of the diaphragm. Now, when the diaphragm shifts, it will shift alongside the reaction disc here because they are attached together. And the reaction disc will push now the piston that is part of the master cylinder. You can see the master cylinder. It will push. So in addition to the effort that you initially applied here, F1, okay, you can call it F1. Na hile ambayo inatoka hapa, the exiting pressure here, I can call it F2. Okay, F2, is way more than F1 because of the action of the pressure difference that is created on either side of the diaphragm. Okay, now as long as your foot is on the brake, the poppet valves will remain as open as possible to have as much atmospheric air remaining in the left-hand side of the chamber. All right, so which means you'll constantly have as much effort as possible, or the maximum amount of effort, that is F2, going into the master cylinder. All right, and now when you withdraw your foot brake, then it will do the opposite. It will let out, because it's a valve. All right, so it will do the opposite. It will let out that, because definitely when you let in air in this chamber, the left-hand side chamber, and that air is allowed to build inside there. It, as long as you are letting in air to a fixed volume, what do you think will happen? Pressure will build up. Okay, if you are letting air into a fixed volume, you will have more and more of air matter, that is air particles or the molecules of air going into a fixed space. When that happens, we normally call it a buildup of pressure. It causes a buildup of pressure because you are pumping air into an environment that has a fixed volume. So which means when you withdraw your foot from the brake, then the opposite action will occur. There will be more pressure on the left-hand side than on the outside. Sasa hapa. Just on the outside, the atmospheric pressure tu ya kawaida hapa nje, which means the flow of air, okay, itakuwa outside, so zitatoka nje. When they move away like that, then the pressure on the left-hand side will be reduced. And what will happen? Then there will be a pressure, what do we call? Like almost a pressure balance between the left-hand side and the right-hand side, which means that there will be very little force on the reaction disc, as well as consequently the piston of the master cylinder, which means there will be almost a total withdrawal of the braking effort on the on the braking system, on the whole braking channel. All right, or the braking system. So basically that's what a brake booster does. So it's very simple. And then from the master cylinder inaenda wapi? Inaenda pale. Now it goes into the four pistons, sorry, the four slave cylinders. So inaenda pale kwa slave cylinders, ingine hapa, okay? All the four of them according to the number of driving wheels that you have, or the wheels that are where the braking effort is required, okay? So kutakuwa na slave cylinders, each of them. Now that is done with. I now want to come back here. So kwa hii system hapa, so like I said, here you have kama hapa. So here unaweza ona that kutakuwa na a piston seal hapa and the slave cylinder hapa tu ndani. Okay? So this one here is what you call a disc brake type. It's a hydraulic operated. Okay? This is hydraulic operated. And then in here you have the master, sorry, you have the slave cylinder. The slave cylinder has a what? Inside hapa kuna nini? There is a piston. That piston presses two things, what you call brake pads. Hii hapa na hii hapa. Kuna two brake pads. Okay? So there is the fluid here is distributed along hapa. Inakuja hapa. Okay, so when you apply force on the piston, just a minute. Sorry for that. So now, I'm saying that there will be an equal amount of force or pressure rather on this brake pad and the one on the other side. Okay, so they'll be pressed inward. So the action here is the brake pads are pressed inwards and they will clamp against the rotating rotor. So here rotor is connected to the wheel through hapa. Unaona hizi wheel studs. Hapa ndio unaweka the wheel. Iko na studs 5. These are 5 studs. Okay, zingine zinakuwa na 4 studs. But they are manufactured together. So the studs are manufactured together with the rotor. Okay? So they are manufactured together. This is where you'd place your wheel. So if you limit the rotation of the rotor, you are basically limiting the rotation of the wheel. That is how they act. So it's very simple. Nothing very complex there. Now I just want to mention something here. You will notice this, that there is something here known as a caliper assembly. Unaona hii? So it's a cut out part. It's not a complete part. You can see here that it is cut out. So it's not complete. So it is cut out like that. All right. So now the caliper assembly is the one that now houses the piston. Sorry, the brake pads. Okay, these brake pads. So they house the brake pads, and they are normally held together in place. The caliper assembly in place with the rotor by. So hapa kuna nini? Just a minute. Just could I take this call? Please allow me to take this call. And then I'll proceed. Okay, so I'll proceed. Sorry for that. So now, so what happens is this, that in the caliper assembly, I don't know whether I have a proper image. Yes, so kwa caliper assembly, these are disc brakes. Kwa hii, this is a caliper assembly, the whole of this. Okay, that is a caliper assembly. So with the caliper assembly, we normally have something around here. See this one here. So we normally call that hole an inspection hole. Okay, an inspection hole. Now, with an inspection hole, you can easily be able to tell the thickness rather. You can easily be able to tell the thickness of the brake pads. Okay, because the brake pads that are used inside of here, and the brake pads, you can see a section of the brake pads inaonekana tu hapo. Okay, on the other side inaonekana tu kidogo. So you can always be able to tell the thickness of the brake pads through by simply looking at the caliper or through the inspection hole in the caliper assembly. Now, so that is usually an advantage. That is advantage number one of this kind of disc brakes. You can easily be able to check without necessarily having to disassemble. But even if you have to disassemble, all you need to kutoa ni hii. Okay, you can see there that there is a bolt. Okay, na hii bolt inakuanga usually it ranges from around size 17 millimeters to around 23. Okay, na unaifungwa very easy, so it's very easy to remove. Okay, so once you remove this bolt, you easily push the whole caliper assembly upwards. Unaisukuma tu iende juu, and then it will expose now the brake pads, which are right here. Okay, now between the brake pads is usually a return spring, a very small return spring. Sometimes it's very easy to miss it. There's usually a small return spring that ensures that if you withdraw the force on the brake pads, then the brake pads are supposed to move outward. Unajua these brake pads, they're not supposed to continually contact the wheel. If once you withdraw the braking force, then they're supposed to move outward. So there's usually a spring, okay, a small return spring here, in that usually around in that shape, that usually ensures, or it always ensures that the brake pads are parted away from the rotor. Because if they continually contact the rotor, then it will always continually decelerate the vehicle, because it will always be resisting the movement of the wheel. Okay, so and then also kwa hizi brake pads kuna kuangana a plate hapa, inakuanga a backing plate at the rear section hapa na hapa, it's called a backing plate. Okay, so to remove it is usually quite simple, especially if you want to do any kind of servicing. For example, you might want to replace the brake pads. And why would you want to replace the brake pads? Brake pads get worn out after some time. You can see, for example, this one here is a perfect, a totally new set of brake pads. Okay, all these are totally new. You can see how new they are. So hapa chini kuna kwanga, like I said, it's known as a backing plate. Okay, BACKING. Okay, you can check it online. So it's called a backing plate. Okay, just a backing plate. So it is so that backing plate holds, there is a material right here. That material is known as a friction material, and that friction material is meant to wear out in preference of the rotor, because the friction material, that you see there, comes in direct contact with the rotor right here. Now, it's supposed to wear out preferentially, which means that you should not, the material that is used to make the friction material in the brake pads is supposed to be softer than the material that is used to make the rotor. So the rotor has to be harder in terms of hardness. I think you know the property of engineering materials. A property of material called hardness. It's supposed to be less hard, all right? So that it doesn't, it wears out instead of the rotor. So the rotor should not wear out. And you know how the wearing happens? Anytime there is that constant contact, especially at very high speeds, the friction energy is usually converted into heat energy. Okay, it's always converted into heat energy. So that heat energy is one that now wears out the brake pads. Okay, so they continually wear out, and then zina reduce, inakuwa less thin, very very thin, and then over time inafika mahali the friction material imeisha, mpaka sasa umeifikia hapa kwa backing plate. Okay, and when that happens you'll see something like this. Okay, you can see worn out brake pads. That is generally how they would look like. So when they are worn out, hapa sasa huwezi ukaitumia kama brakes. In fact, they will not function as brakes. Why? Because now the material that will be remaining, this is now metallic. Now this metal, there will be now a direct contact between the metallic part of the brake pads and the metallic rotor. Now, none of them will wear out in preference of the other. In fact, because of the fact that it is the rotor that is rotating and the brake pad is stationary relative to the rotating rotor, then it will be like you are wearing out the rotor using the brake pads. You know why? Think, for example, of a lathe machine. Okay, what do you normally do? You normally hold the tool stationary, and then you know, kama unafanya turning operation or a facing operation, then it is your component that is rotating. So which one will air out? So because of the fact that one is stationary, the other one is in motion, the one that is in motion will always be worn out more than whatever you are. Regardless of even whether when you have the same when you have the same hardness, okay, the one that is in motion will always tend to wear out more because of the added rotational energy. Okay, so the rotational energy itself will even increase the rate of wear, especially when it comes to in contact with any other parts that is stationary or relatively stationary. All right, so that's what I meant. So when the brake pads are worn out to this extent, then sasa it will function as a tool as if it's a lathe machine, and I can assure you that it will let away the rotor. Okay, so I found myself in this situation some time back. I knew that I was supposed to do the servicing of the brake pads, lakini you know Africans, we always say nitaitengeneza tu next week, nikipata pesa nitaiweka, hiyo si issue. It's very very easy. Okay, and at that time I had all the I was working in a place where we used to do it for a lot of clients and all that. So this kind of just laziness in the head. And one time I decided to take supper and nikasema siwacha nifike tu my rural home. My rural home is quite far. It's more than 300 kilometers away. Na mimi nimekula supper Sunday, nikashika gari. Nikafika Narok, nikasema acha nikunywe chai sasa re-energize, alafu sasa niendelee na kazi. I'm telling you, the moment nimetoka Narok hivi, I'm applying the brakes, the car is not coming to a stop. When I was actually parking it, naanza kusikia some scratching sound, some very uncomfortable sound. And then I find out that nikajua, in fact, the moment nikaanza kusikia that noise, nikajua too, that is it. Sasa hiyo mimi niko Narok, it's 1:30 AM, the middle of the night. Not a single mechanic on site. Nimejaribu kutembea, and again, it's also not so safe to walk around just like that. Nimeacha gari hapo, trying to locate. Even if you can get a mechanic, where would you get a shop selling those things? When it's not simply impossible. So ilibidi sasa nimeenda very slowly kutoka hapo around 40 kilometers per hour, a journey that would have taken me about 2 hours. It took me almost 4 hours because sasa pia siwezi enda na speed. Kikaribia gari ingine, and you have to make an emergency stop. That is another problem. Okay, and again also, even if I were to sort of maintain a higher speed, anytime you kanyaga hizo brakes, you are wearing out the rotor. Okay, and when the rotor gets worn out, if it's excessively worn out, by the way, you can always take it to a lathe machine. Kuna or a milling machine, and you can do some turning. Is it turning or facing? Nyinyi watu ndio mmefanya lately hizi vitu. I think it's facing and turning. Which one reduces diameter, which one reduces the thickness? Hebu mniambie the difference between turning and facing. I have forgotten those things. Yeah, it's skimming. You call it skimming. But what is the nature of that machining process? What is the name of the machining process? I think there's a proper technical name. Is it turning or facing? Yeah, I know we normally call it skimming, but what is the lathe operation? I think it's because it's either turning or facing. Anyway, so what you do is that you normally impart a more uniform, that is surface, a very uniform surface area along it. Lakini pia you always have to take care. It has to be done by a professional. Okay, najua sometimes, you know, hata hapo tu, I'm sure probably unaweza chukua ukafanyia hapo tu kwa tu. Juu inafunguliwa tu the whole of this rotor and then unaipeleka tu pale kwa lathe machine, you grip it, you ensure that you have a proper tool in place, then you can do that. Okay? But I think you'll always have to also take care, because there's also a certain degree of thickness that you cannot reduce the rotor to. Why? Kwa sababu if it's also too thin, remember that you'll require more effort. And I know somehow you can adjust the positioning of the pistons and all that. So kuna watu wenye wanafanyanga that kind of size. You can adjust the position of the pistons, especially if the rotor umefanya a lot of that skimming, as John calls it. But remember that if there's also excessive wear on the rotor, okay, because of any kind of operations you've done on it, inafika mahali it is too thin that you have to apply so much effort for the car to come to a stop. It becomes a problem. All right. Another thing is that if also you don't do any kind of if, for example, it was worn out by the brake pads, and then you come and replace new brake pads. Remember your surface area very rough. Now, if it's very rough, then it means that it is going to wear the brake pads so fast, the new brake pads. And then the problem is that it might wear them out unevenly. Moja is getting worn out more than the other. You might find that the one on the right hand side and the one on the left hand side are not uniformly worn out. So again, even applying braking effort is not going to be uniform, because the braking effort should be almost uniform on either side of the rotor. All right. So it becomes a kind of a problem. All right. It becomes a kind of a problem. So anyway, so that's what I just wanted to mention. Now, another thing I wanted to mention is this, that if you see the specific design of the caliper, of the disc, okay, ukiona hapa, they have surfaces of heat loss. Okay. They have specific surfaces of heat loss. Now, these ones, remember that I said that the nature of braking is that you have to convert, two things have to contact each other. One will lose energy. So the energy from the rotational energy of the rotor has to be transferred somewhere. Remember, from first law of thermodynamics, the energy, if you are losing energy in one body, it will always go to the other body if those two bodies are in contact. Even when you lose energy in a body, it will go to the environment or the heat sink. Haiwezi ikapotea. So the rotational energy, your energy from the rotating rotor, kama unaijaribu kuibring to a stop, where will it go? Lazima iende mahali. It will be transferred as frictional energy and then converted immediately into heat energy on the surface of the rotor and the brake pad. Okay? Now that energy pia lazima iende mahali. Unajua, by converting it does not mean you have lost it. It is still there. Lazima itakuwa hapo. Now you cannot accumulate heat energy inside these kinds of components. It could easily heat up everything, ichome kila kitu. What do you do? Now the rotor, the design of the rotor is that the material first of all allows for very fast loss of heat. Okay, a very high rate of heat transfer. And then also you can see the specific design of the rotor. Inside that, it is not a solid part. Okay, so it has a lot of surface areas that allow for higher heat transfer rate. And which means, therefore, that disc brakes, by the very nature of their design, are more efficient in losing heat compared to this one here. You can see for the drum brakes, everything is usually contained inside. So this part is connected to the chassis. So chassis is inside. These are instead of brake pads, this kind of system uses what you call brake shoes. Okay? And then the drum itself is called the drum. Okay? We call it the brake drum. Najua inakuwa confusing. Drum brakes is the type of the brake system. Now brake drum is now the drum that will now cover everything. So which means the shoes will always be covered inside the drum. Okay? Itakuwa kila kitu. The drum always covers this. So which means the brake shoes in the drum brake system are not directly exposed to the air, and neither is the drum itself. The inside, because heat is developed inside the drum, on the inside of the drum, because what happens is that these shoes the way they act is that they move outward. You can see here. These shoes act by moving outwards when you apply the brakes. Okay? They move outwards. Now hii drum hii ndio ina rotate pamoja na miguu. Okay? So the drum itself, the one on the outside. So basically hapa ndio you have the studs will always protrude from here. Okay? The studs are always protruding from here, and then here is where you have your wheel. So when the brake pads move outward by application of force, they will press against the rotating drum and therefore bringing the car to a stop. And therefore, the friction is developed inside of the drum because the drum covers the shoes. All right? So what does that tell you? It tells you, therefore, that any heat generated in these drum brakes is not easily dissipated compared to this system. Okay? It's not easily dissipated. Okay? So now that brings me to another thing. The rate of heat dissipation, the efficiency in which heat is lost, is what determines the efficiency of the braking system. You know why? If heat is allowed to develop between the brake pad, for example, in this one, in the rotor, or the brake drum and the brake shoes, that excessive heat built between the two surfaces will cause some loss of braking effort in a specific a specific phenomenon known as brake fade. Okay, so it causes something called brake fade. Okay, so brake fade is when there is excessive buildup of heat between any two contacting surfaces in a braking system. Okay, and it will cause a temporary loss of braking effort, which means kuna mahali utapata saa zile una brake sana, especially kama unaenda haraka, unakanyaga kwa jam, unakanyaga brake, you are moving brake all the time. It reaches a point where, say for example, you're at high speed and you're trying to apply your brakes and you sort of feel like the vehicle is not responding. I don't know if you've felt of that. Nimekuwa nayo mara mingi because sometimes, especially kama unaenda at night, maybe njia is very clear, you can see, and then all of a sudden kuna kalori kana overtake pale, and then you try to apply the brake, unajaribu to move towards the side and all that, always constantly applying the brake and all that, and then ama umeona immediately after maybe umeona a bump and all that. So that kind of constant application, it reaches a point where somehow you feel as if una apply brake but the car is not responding. That is what you call a brake fade. All right. So these brakes are able to the feature of brake fade is such that it is an inefficiency in the braking system. All right. So it becomes it's counterproductive to the braking system, and the easier it is to lose the heat being built up, the more efficient the braking system. So disc brakes are generally more efficient compared to the drum brakes because of their design. All right. Now, so that is number one. Now, another thing is, so we've talked about these ones have shoes. So usually, if the vehicle is moving in this direction, heavy, then the ones at the front are normally known as the leading shoes. The ones at the back are normally known as the trailing shoes. Okay. Now, when you withdraw the application of force, kuna kuanga na springs hapa. Now, this spring normally has an extension type of a spring, and it will bring the shoes to their neutral position so that it does not keep contacting the drum. All right. So, and by the way, kuna kuanga na a certain gap that is normally left, or some gap or some clearance that is normally left between the lining, inside lining of the shoes as well as the wall of the drum on all sides. Okay, do you know why? Kwa sababu the brake drum rotates while hii part yote hii hairotate, hii yote hii, which is basically here, hii na hii hairotate, while this drum rotates to the wheel. Okay, so the rest of it is basically stationary. So which means lazima kukuwe na some clearance to allow for that rotation. Okay, so because they rotate concentrically. Okay, the drums rotate concentrically inside that system. So that gap, if that gap is not maintained, say for example the gap is too big, okay, there's too much of that gap, then it means you require to apply too much braking effort before the shoes can contact the rotating drum. The gap is also too little, the clearance is too little, then utakuwa apply kidogo tu shakanyaka brake hivi, then gari shasimama. So there will be only a lot of sudden braking. Now you always adjust that gap using an adjuster. So kuna na adjuster inakuwa tumeno, inakuwa na tumeno. I wish I had put some image here, but inakuwa na, so it looks as if quite a number of them, if you see them, it would look as if it's some sort of something that has a small gear with spurs, okay, with some teeth, or it could look as if it's some sort of a small sprocket, okay, which you can easily adjust manually. Okay, you can easily do some manual adjustment, and it will move the shoes either inward or outward depending on the kind of adjustment that is required. So kuna kwanga na a way of the when it is free. How do you know, by the way, whether whether it is the adjustment is the correct one? So one is that kuna kwanga na a chart ambayo unaitumianga unapima that clearance and then you check against the chart, okay? Alternatively, I've seen quite a number of mechanics would ordinarily not need it. What they normally do is that they normally adjust and then assemble the drum brake, and then they would rotate, apply some rotational force. Kwa sababu nilisema hapa kwa drums kuna kwanga na studs that will exit inapita through those holes, the ones that are you used to mount the wheel onto them. So they will use those studs to rotate the drum and then see how fast it comes to a stop when it is freewheeling. Okay, so if it comes to a stop so quickly, I think most of them would wameshajua how fast it should come to a stop. If it's too fast, then it means they still need some adjustment. If it freewheels for a very long time, then it means you still need to adjust now outwards. So but so hiyo ni kwanga ni ile nasema ni trial and error. Sometimes kuna vitu ambazo utazifanya over time once umeshajua what to expect, especially with experience. But then again kuna kwanga tuna you can easily just take those measurements, measure the clearance physically, and then you can be able to check the charts, and then unaweza tell what is the one that would be most suitable, especially when replacing the new shoes, especially when placing the new shoes, because it's much easier to tell when the shoes are also very new. So it's something that unaweza pima, and then you use a chart to know how much of it you require to adjust. But I've seen most of the mechanics, they'll just use their own experience and all that. All right. So anyway, so all I'm saying is this, that generally replacing, for example, the kind of maintenance that you normally do for this kind of drum brakes is that once in a while, because of the way the drum brakes go, they would, because of the fact that they are normally enclosed, they would normally enclose everything. Unajua inakuja ina contact up, and then it encloses the shoes inside. Sometimes it tends to collect dust and other particles. All right, from time to time, they just collect dust. They'll collect some other, foreign materials. Sometimes water goes in, then it dries up and it forms mud with the. Kuna some debris that sometimes from time to time would collect there. So maintenance yake, and when they do that, then you'd have sometimes this debris coming in between the shoes and the drum itself, and then it reduces your braking effort as well. So one of the things is that from time to time the drum brakes sana sana huwa inatolewa, and then you simply blow compressed air inside, and then it will clean it. Okay, so and sometimes and this one does not even need anytime, for example, you have access to compressed air, we would just do it for clients, even as just was part of the free service. Just as part of this free service, just check or once you've, say, for example, done maybe oil replacement, oil filter replacement, air filter replacement. Sometimes you just check the brakes, just as part of the free service that you give for the client to come back. So unaenda tu na check also the thickness of the drum brakes, uone kama they are worn out, if they are still in good condition, just blow in compressed air, and then it will generally just clean it. Now pia unaweza tumia, okay, from time to time, especially when there's, unajua unaweza kunapitia all the time, kama kukai umetambulika na rainy season, sometimes a lot of water collects inside the drum. And sometimes it's not just ordinary water. Sometimes it could be water mixed with oil or some corrosive agents. Sometimes utapata kuna some level of corrosion that would develop kidogo tu inside the drums. Although the material that is made inside is supposed to be highly resistant to corrosion, but when there is too much of this, sometimes the water is kuna acid ndani, kuna oil, kuna nini. So sometimes utapata kuna some amount of corrosion that will develop inside the brake, the drum. So what you do is that you can use an emery paper, okay? So you can use an emery paper and simply clean on the inner edges of the drum, just to ensure that the surface remains smooth. So it must remain smooth for it to act properly, especially when it comes to in contact with the shoes. Okay, so you can also use an emery paper to clean it. It's just a part of the process. So one thing is that you can check the thickness and also just generally clean it by either using compressed air or an emery piece of cloth. Okay, you can also check the spring. Sometimes also the kind of adjustment that you do inaweza kopia ni spring imefail, because hii spring pia huwa inafikanga mahali na fail, so it's something that you can always replace, and it's quite easy to replace this spring. But generally ukiona kufungua hii, sema kufungua the drum brakes system, compared to this one, hii ni rahisi sana ku replace, because nilikuwa nimesema ni kutoa tu stud and then you can replace. In fact, by the way, if you have a car or your parent or your somebody has a car, kubadilisha kama hizi disc brakes zinakuanga ni kitu rahisi sana. Okay, kubadilisha hizi zinakuanga ni rahisi sana, one of the easiest thing. Ukishatoa mguu, you simply unafungua tu nut. If you have the tools, that is, yeah, unatoa tu, it's not a nut but a bolt, sorry. So unatoa tu your bolts, naifungua. As long as umeona to the sequence in which you can assemble back, because saa zile unazitoanisha, also have to, you can take a picture. Saa zile hata unaifanya mara ya kwanza, and then you just know vile itarudi. And then you can take those two pairs, take it to some shop where they sell genuine parts. Mwambie hata kama ujui the part number ya hiyo for that specific car, just go and take it to those guys wenye wanauza, they are dealing them kama town pale Impala, inaitwa Impala what, yeah, normally have some genuine spare parts and all that. Then mwambie kupatie mpya, ataiona na atajua. Wale wameuza especially hapo wapi, wherever, Kirinyaga Road, wherever, yeah, as long as usinunue kutoka Akora, but they can always see it and know the exact part number, and then you simply come and replace it na unaifunga na unaenda na gari yako, and then you test it. And by the way, saa zile unaitoanisha, sometimes the pistons exert a lot of force on the brake pads. So when they do that, sometimes you have to press the pistons slightly outward so that it can release the grip on the brake pads. Okay, so usually you do that, you know, as the brake pads wear out, the pistons keeps adjusting to match, okay, outward. So saa zile unakuja una replace a new one, you have to push the piston backwards, because now when the ear amount utakuja kuweka iko na a larger thickness, so you sort of have to press the piston inward. And you can use kuna different types of tools, but sometimes that if you have maybe even a flathead screwdriver, as long as you know how to use it properly, you can always use it in conjunction with a cloth, and then you simply push it inside. Okay, but it's not kuna na certain tools ya grip the piston, so that you can adjust the piston ndio kukuja kuweka. But once umesha kuzireplace, then umefunganisha, and then you are ready to you normally just switch on your car first, and then you keep pressing the foot pedal, all right, to ensure that the fluid is uniformly distributed to every piston, especially kwa hizo ambazo ulifanya replacement. And by the way, remember this, that when you replace the disc brakes on one wheel, lazima replace on the other one. Kama ni the two pairs at the front, I mean the front pairs of wheels, the front pair of the wheels. So if you replace it on the front right wheel, you must replace it on the front right wheel, even if the ones on the front right wheel are still relatively new. Okay, so that you want a uniform braking effort on all of them. Because if one is slightly worn out compared to the other, when you are driving, anytime you apply the braking force, especially when you're at high speeds, sometimes the one that is worn out will tend to pull you towards that side because it's getting less braking effort. So the car will attempt to stabilize towards that. So it imparts something in vehicle dynamics called a roll motion. Okay, No, not a roll motion, but a yaw action. It's a yaw action. All right. So it's called a yaw action. Okay. So now, so it sort of tends to pull you towards the other side. The kind of feeling that you also get when you have a misalignment in your wheels, and we'll talk about wheel alignment sometime. Okay. So inakuanga tu ni mzuri kuzireplace at the same time. I always want to replace it at the same time. The same thing na zile za nyuma. Okay. If you also replace them. You will always replace them in pairs generally, just so that you can have, especially it's more critical, especially from the driving wheels. Okay, because kwa driving wheels is where all the action happens. All the action happens there. Now, you will see something here that in terms of nataka uone design ya hii, okay, compared to this design of the drum. You can see the drum is very simple. Everything else is very simple. Okay. Now, if you compare that with this design disc brakes, you can imagine the kind of machining processes that goes into producing this specific shape of the rotor, including here the studs. Generally, because of this complex shape of the disc brakes, they are more expensive compared to the drum brakes. Okay, they are more expensive. They could be easier to replace, easier to maintain, but they are more expensive. It's a more expensive technology. And you know why it's also expensive? It's because it's more efficient. Okay? It's more efficient. So, now, if that is the case, then you require, okay, let me just, let me use this. I'm going to use this. If you see this image here, generally, kwa gari, especially the economy type of vehicles, I normally call them the economy type of vehicles, the sedans, you know, Nissan March, some of these ones, you know, the Allions, those kind of mid-level vehicles or mid-range vehicles. These are two, especially from the mid-range SUVs to the small passenger cars. Sana, they are normally designed for use with the what you'd call maybe the middle class or something, for lack of a better word. So it means that cost is a critical factor for this kind of cars. Now for that reason, therefore, utapata sana magari za mbele inatumia disc brakes, while miguu za mbele inatumia disc brakes, while miguu za nyuma zinatumia drum brakes. You know why? It's a cost decision issue. Okay, it's a cost decision issue. All right. And now, because it's a cost decision issue, you could as well have used drum brakes all through because they are much cheaper. Lakini, you want the more efficient ones at the front. You see the more efficient are placed at the front. You know why? Kwa sababu, when you brake your car, ukikanyaga gari, you know Newton's first law of motion. You've probably studied Newton's first law of motion. That any kind of a braking action, for example, just to paraphrase, if there is a kind of braking action in a vehicle, the front wheels act as the pivot in terms of absorbing the inertia. So kunakuanga na ile inertia that is built together by momentum. You know the equations here, momentum, right? That is from Newton's second law of motion. So that momentum is always converted, it's always carried together with the vehicle, and it would normally be felt as what we call inertia. That's why if you stop something, it will attempt to continue moving in that direction. That is what I would define as inertia. So when you brake your car, the front wheels act as the pivot. Okay? So that all the force comes there. So therefore you want the more efficient brakes at the front rather than at the back. So if it's a cost decision issue, then you just have the less efficient one at the back. In any case, by the way, you can replace the discs, okay, the discs, even 5 times before you replace the shoes. Okay, the shoes do not wear out as much because, like I said, most of the braking action opens at the front wheels. All right, they open at the front wheels. So that is generally the reason why. So it normally just a cost decision issue. However, for SUVs, utapata kwa SUVs, all of them zinakuanga ni disc brakes. Ukipata pia race cars. Why? Kwa sababu for those kinds of vehicles, cost is not usually a factor. Yes, it is a factor, yes, but it is not a primary factor. The primary factor is when it comes to the high-end SUVs, the high-end race cars, and high-end the muscle cars, the sport cars, all right? You know what the greatest factor inakuanga ni? Ni comfort. Comfort and status. Kwa sababu ukifika mahali unanunua gari kama hiyo kubwa, okay, unanunua ZX V8, ZX Land Cruiser, that means pesa sio shida. So we don't bring in, yes, cost iko hapo ndani, but it is not usually a major factor. What is usually a major factor inakuanga the torque ya gari, inakuanga pia in terms of the speed. Kuna quite a number of things you'd see, like the speed, torque, acceleration ability, the luxury, the aesthetics, luxury, status. Okay, so kuna quite a number of things that are built into those cars that you will not find maybe in the ordinary cars, where mtu tu anataka kukua na gari ya move from point A to B, then you want to keep the cost as chini as possible. Okay, and I'm still in that bracket here, my hustlers, where you want to make sure you keep your cost down. Okay, but siku moja tu you'll also go to where money is not a problem. Okay, but I'm just generally giving you a picture for you to be able to understand what goes into those kinds of design decisions, especially with this type. Now, so nimetoka hapo. There's one more thing nimesahau tu hapa. For the these are worn out shoes. Zikikuwa worn out inakaanga hivyo. All right. So these ones. Now, with the shoes, in most cases, if one of the ways you kujua that they are worn out, you'll always hear some kind of noise, some very uncomfortable screeching noise coming from the back, okay, especially during braking action. So the diagnosis inakuanga tu, the only thing is just to kuifungua. Okay, when you have the right tools, pia unaweza kuifungua tu ukaiona. All right, naifungua tu, then you can access it, you check it, the thickness and all that, and you can easily know when it's worn out, especially kama hii yenye unaiona, for example, it's totally worn out, so it's supposed to be replaced, and a new one you can see it looks like that. You can also see that iko na friction material on top of it. Okay, this is the extension type of spring in the return spring, even ndio inakaanga. Okay, so return spring iko ni extension type of spring, not a coil type. I hope you know the difference between a coil type and an extension type. Okay, now another thing that I also wanted to mention is that when you have this arrangement, if this is the front of the vehicle, and this is, we call this on the leading shoe, this one is called the trailing shoe. Now, kuna certain arrangements, I don't know whether you may have come across it. This is still the front of the car, lakini brake shoe moja iko hapa juu na ingine iko hapa chini. The brake shoes are like up and down configuration rather than front and back. Now, this kind of configuration, we call, both of them are leading shoes. None is trailing. Both of them are called leading shoes. So utazipata, I have seen, worked on some few cars ambayo ilikuwa na this kind of configuration. It's a bit confusing, but ziko. I worked on one of them, was an Isuzu. It was Isuzu. It was a pickup. I've forgotten the specific nini, but it was a pickup. And by the way, ilikuwa kwa miguza mbele. I think it was a 1995 model. It was an Isuzu pickup. I've forgotten the exact model of that car. Okay. Now, so ilikuwa na drum brakes kwa mbele, both mbele na nyuma. And then the drum brakes ilikuwa na, both of them were leading shoes. Okay. But it's not very common these days. But yeah, all I'm saying is that you can also have that kind of configuration here. We have both leading shoes. All right. You can also have both of them being leading shoes. So another thing is, I don't know whether there's anything else I may have forgotten. Mtuka kuona. Hiyo nimeshaeleza. Okay, pia kuna hizi electromagnetic brakes, electromagnetic brakes. Okay, this one I want you to go and read about it, but inatumia the principle of electromagnetism. Now, for electromagnetic brakes, you only create an electromagnetic field. Okay, an electromagnetic field. So electromagnetic field simply creates, you know how a magnet works, so it sort of creates an opposite polarity on the component which it's supposed to bring to a stop. So it simply creates a negative polarity. If the polarity on the part where you're supposed to stop it is north, this other polarity is also north. So they will resist each other. So when they resist each other, then it sort of brings about to that other component to a stop. So I want you to go and read by yourself about the electromagnetic brakes. But kitu unafaa kujua na electromagnetic brakes is that there are no contacting parts. So which means for electromagnetic brakes, and you will find them, for example, in some EVs. Okay, iko na this type of electromagnetic brakes. I actually have some students they are doing a project on developing electromagnetic brakes for slowing down a rotating shaft that can be used for ball mills, for hammer mills, and all that. I have some students I'm supervising. They are B and Jama BTech. I think they are BTech students. I don't know, but wako tu hapo okay. So we have so electromagnetism can also be used as a form of braking system. All right, and so I want you to go and read about how electromagnetism. Now the beauty of this one is that hakuna any two parts that are contacting. So which means that kuna very little effort. There is nowhere of any part. So hakuna anywhere and tear. So hakuna to replace anything. Maybe the only thing that is replaced are the electrical components, kama capacitors, maybe things like those. All right, but they move the part. There are no parts that are contacting each other, so it is the most efficient type of braking system you can get because there are no anywhere kuna mahali kuna contacting parts and there's wear and tear, then there's inefficiency. In fact, by the definition itself, any two parts contacting each other and one is moving relative to the other, already you know that there's power loss. Hapo tu kabla tu waanze. And brakes are meant as, are designed to be a power loss device or an energy loss device. That is, it captures the rotational energy of the wheel and then dumps it by converting into friction energy and then by capturing it in form of friction energy and converting into heat energy and then losing it. And that is how it comes to a stop. So it is a brake system or braking system is generally a heat loss device. Now, so this one here it's the most efficient of them. Kuna pia pneumatic brakes. I also want you to go and read about pneumatic brakes. You can see generally, so pneumatic brakes, the only thing you want to know about pneumatic brakes, na utazipata kwa hizi malori, I'm sure umezisikianga kwa hizi malori, nini and all that. I need to read about it. Lakini the only thing I will tell you about the air brakes or pneumatic brakes is that it requires, for example, you can see here that there is a reservoir tank. So lazima kwanza ukuwe na compressor. So inatumia compressed air basically. Okay? Don't know whether you've used compressed air anywhere. Yeah, I think you probably have used it even in your workshop and all that. All right? So you compress the air and then it's stored in a reservoir. Okay? And then it is supplied on need basis now to what? So through the delivery valves and then now to the brakes. Okay? So the action of the brakes is basically the same as those of the ones that are hydraulically operated. But the mechanism of supply of the energy for the braking system is slightly different. Why? Because you are using compressed air rather than hydraulic fluid. Okay? Now, the only thing I'll also tell you is this, that pneumatic brakes are more efficient compared to hydraulic brakes. Okay? They are more efficient. They are way more efficient. If you want to know this, I don't know, also kama maybe I know some of you have worked in workshops before, maybe kuna nyata wanafanya kwa workshop, any kind of workshop. You'd find that kuna kuanga na hizi hydraulic lifts. Okay? Kuna kuanga na hizi hydraulic lifts. Yeah? Ambazo zinatumika ku lift the vitu and all that. But I don't know whether you probably have worked in a workshop where there are these air lifts. Okay? That's now to make compressed air rather than hydraulic fluid. Yeah? They are much easier. The force delivery is usually much more instant compared to the to those of hydraulic to hydraulic systems. Okay, the delivery, that is, once you compress and you capture it, you can easily deliver it faster, way faster than hydraulic system, because for hydraulic system the oil moves in a lot of viscosity. Air does not have that kind of a problem. All right. But remember also, air has some elements of compressibility, which hydraulic fluids do not. All right. But in terms of delivery, very instant delivery of stopping action, then the air brakes would be, the air brake systems would be much more, what is the word? Preferred. However, the question would be, Kama they are more efficient, then kwa nini hazitumiki kwa gari zote? Okay, that would be the question. Why are we not using it, for example, for small cars? Kwa nini hatuitumii kwa Suzuki Alto? Okay, ama Nissan Note or whichever type of a car that is. Now, so I'll just mention the reason is this, that unlike hydraulic systems, which only require, for example, you see the just very simple master cylinders, just a brake booster, master cylinders, and slave cylinders. This one, kwanza, lazima uko na compressor. And you must have a way of driving that compressor, right? Which means you draw energy from a battery. That battery would still need to be, the energy would still come from an alternator. That alternator is, that drives this power from the engine. All right? So you have to find a way of powering that compressor. Again, you need a reservoir tank. Okay? This one takes up space. Tukianza tu hapo. Sasa tupata sana sana ni lorries and the maybe heavy commercial trucks ambazo ziko na air brakes. They can be used in conjunction with hydraulic brakes, just as a redundancy method. All right? So kwa sababu ziko na space along kwa chassis, lakini gari ndogo utaweka hapi. So hiyo tu ndio inakuwa ni shida. All right? Others, they are more instant. They would even be better even in what do I say? In emergency situations. Okay, they usually deliver more instant braking action. Now, so shida sasa, so inatumikanga sana sana. That's why with heavier vehicles, because of the issue of momentum, they'll be used. They can also be used either alone, or they can be used together with hydraulic braking systems, just in conjunction, the two of them. Okay, just two different delivery lines, but working with for the same goal. Okay, and there's usually a safety valve here that normally drains excess. Unajua peer pressure haiwezi ka build beyond a certain point, so there's excessive buildup of pressure. There could be, this valve here could be one, sometimes that inaweza kuwa imeharibika and all that. So if there's excessive buildup, it normally releases it through a safety valve. But hapa chini kuna kwa na drain cock. So once in a while pia they are normally just drained, because with time, sometimes if the air has too much moisture in it, for example, there is a lot of air, a lot of H2O molecules, that is suspended H2O molecules. They normally, when the vehicle cools, they normally turn into water. So from time to time, zinakuwa drained. So from time to time, then you drain them. Okay. But the safety valve simply ensures that there's an excessive buildup, then it releases. Okay. It's usually just a built-in safety feature. So that is it. I just wanted to mention kwa air brakes. I don't know whether there's anything else I may have forgotten, but kama kuna anything else, you can always ask in form of a question. So there's something else that nataka tu just to bring it to your attention. Kuna vitu ambazo nimeongeza hapa, just the self-check questions. Meanwhile, kama kuna swali, I attended the class to end at 9, we still have 8 minutes. So kama kuna mtu akona swali, just type it up kwa the public chat, and then nitajibu. Now, so kwa self-check questions, so hizi nataka tu mkienda, you just go and read about them. Explain how the ABS system works. ABS, the anti-lock braking system. Okay? And then utumie illustration. So hii nataka muende mjisome how the ABS system works, kazi yake ni nini, and then use illustrations. So like I said, you have to be supplementing your own notes as well. I will not give you everything. Okay? I'm not sure whether iko kwa notes, it could be there, it may not be there, but you should know how to explain how the ABS system works. The other question is, what is brake fade? Brake fade ni nini? What could cause a vehicle to pull to one side when braking? Okay? Utatuambia ni nini? Discuss how cost and system complexity influences the choice between drum brakes and disc brakes. Okay, nilikuwa nimediscuss, but now you need to put it into words. Okay, now the other one is discuss how cost, maintenance requirements, and system complexity influences the choice between hydraulic, pneumatic, and electronic. Okay, that is another one. Why are pneumatic braking systems commonly used in heavy vehicles while electromagnetic braking are less widely adopted, despite the advantages? Na nimeongea kuhusu advantages ya electromagnetic braking system. Lakini kwa nini hazitumiki if they are more efficient? Why are we not using them? Why are we going for pneumatic braking systems? And definitely electromagnetic brakes are definitely more efficient. So that is the question. So you go and just discuss about them, and they'll help you to understand the topic more. Okay, that's all I wanted to say. So kama kuna swali, we still have some 6 minutes. Kama kuna swali, I can take up a question or two. I'm hoping that you're still all there. Najua webi wengine wameshachoka kidogo, but hufai kuchoka because you only get to do a class. But I'm happy I'm still seeing some about 19 people here, and I'm told you are normally around 20 something, so it is a good thing. So I hope mtu akuweka na akapotea. It's always important to follow the lecture. So kama kuna swali yote, I'll be happy to listen to it. Now, so now, meanwhile, as I wait to see the question, the other thing I would like to say is, so the class rep, we can do a question, a class tomorrow from same 6. So we can do like a 1.5 hour class around there, but it's not a very long class. Itakuwa like 3 hours kama hii. So just some few things that we talk about, so that we also don't lose. Staki vitu za kufunza mwisho sana. So if we can do that, then maybe from next week you can tunaweza decide when to do a cut, because at least you've done some material as you can do a cut, and then you can also determine how to do the cut. So at least we can do tomorrow, then we'll also meet next week. We can also do on Saturday next week again, and then I think from there to catch up, and then now we can proceed normally going forward. But I'll be more comfortable if we can sort of catch up with the rest. Yeah. So we'll meet tomorrow and tawatumia link 6 p.m. Then we'll proceed. Otherwise mimi nimemaliza, sioni swali lolote so far. So kama hakuna swali lolote, let me thank you guys for your patience. Yeah, imekuwa a lot of time. It's almost 3 hours since we started. Actually 3 hours. Yeah, nawatakia kila laheri. You guys go sleep well. Wala kona familia. Greet your families, and we meet tomorrow again, Mungu akitujalia. Asante sana. I can just people typing you kama, yeah, good night. Yeah. Sasa asanteni. See you tomorrow.